Hello, let's do checkpoint 2.38. They want us to find the area of the parallelogram spanned by, parallelogram with vertices P, Q, R, S. And they give us values for P, Q, R, and S as points. Let's try to imagine how this thing might look like by trying to plot these points on the X, Y, Z space. And we'll start off with our P. Our P is 110, 110. It looks like it's going to be a point on the XY plane. Q is 710, 10. So it looks like it's going to be also on the XY plane. And our next one is going to be, our R is 942. 9, 1, 2, 3, 4, and up to 2 units up. And then our last one, S, is 3, 4, 2, also up. Okay, hard to picture now, but it looks like we have our values. And let's make the connections, and this is the point Q, and we connect Q to R, and then R to S, and then S back to P, that's our vector S, and then P was the starting point. It's kind of hard to see, so we usually prefer to take this kind of swiveled out of context, and let's just pretend that we've taken it so that we have a slightly different point of view. We have our vector P, or our point P, and then we have our point Q. And then we have R, and then we have another point S, and I'm drawing these with slightly different colors, and notice the two vectors that I just drew from P to Q and P to S. It turns out that these are going to be the vectors that we're going to be interested in. Let's call this one V for our vector going from P to Q, and then let's call this vector W going from P to S. It turns out that if you want the area of a parallelogram spanned by two vectors, which is essentially what we have here, that the area is going to be equal to the magnitude of the cross product of the vectors that span that. Okay. All right, so now we have to find each of those vectors. What is our vector V? Our vector V is the difference between Q and P. So V equals Q minus P. And Q is 710 and P is 110. So 7 minus 1 and 1 minus 1 and 0 minus 0. So we have our vector V. Now let's find our vector W, which is S, the head minus the tail, S minus P, and S is equal to 3, 4, 2. So 3 minus 1 is 2, 4 minus 1 is 3, and 2 minus 0 is 2. Okay. Now we have the vectors that we want, and the next step is to take the cross product, and then we'll take the magnitude. So let's take the cross product of V and W. And for that, we'll set up our matrix I, J, K. Our V is 6, 0, 0, and our K is 2, 3, 2. Now, let's get this set up in the I direction. In the I direction, it's going to be 0 minus 0. Let's put a negative sign for the J direction. In the J direction, it's going to be 6 times 2 is 12. 2 minus 0, or 2 times 0 is 0. And then in the K direction, we're looking at crossing out the K. We have 6 times 3 is 18 minus 2 times 0. Okay. What do we have? We have 0, negative 12, and this is 18 minus 0, so that's positive 18. All right, this, well, this is not the magnitude yet. Sorry about that. This is just the cross product, and the cross product is a vector, and this vector, if we take a look at this drawing, has a positive z-axis and negative y, and it doesn't move along the x. So I think this vector will look something like this. Not that it's necessary for us for this problem, because all we want is the magnitude. But in any case, we can see that it looks like it's going to be perpendicular to that parallelogram. Okay, let us find the magnitude to get our area. V cross W magnitude, and this is going to be our area, and that is equal to the square root of 0 squared plus 12 squared plus 18 squared. That's 144, and 18 squared I think is 324. And this gives us a total of a square root of 468. Okay, so that is the area of the parallelogram with the vertices of the given points. Okay, I hope that helps.